Hello folks, and welcome back to another lesson. Today we're going to be talking about polynomials as well as roots and zeros. Now what we're going to get started off with is trying to solve or trying to sketch a graph using only what we know about solving by graphing and end behavior. We're not going to use the axis of symmetry or a vertex. So let's start by trying to figure out the end behavior here. For this problem, y is equal to x squared plus 1x minus 6. Our n is going to be even. We have an even power, and our coefficient is positive. This means that our end behavior is going to be up and up. Okay, what about solving by graphing? Well, if we were to substitute in 0 for this, or if we were to just graph, we would try to make this so that we know where our x-intercepts are. The x-intercepts would be where this is equal to 0. Or in other words, it would mean that x plus 3 has to equal 0, or x minus 2 has to equal 0. So we know we're going to have x-intercepts at negative 3 and positive 2. Let's go ahead and mark those down. 1, 2, 3. So we have an x-intercept at negative 3, and we have an x-intercept at positive 2. Additionally, we know to the far left and right, these values continue going up. So now all we have to do is we say, well, what does a parabola do in the middle of this area? Well, it's going to curve down and then reach back up. And this is our graph, our basic graph of this equation. So what's the essential understanding here? It's that these factors that we have, x plus 3 and x minus 2, are the same thing as the x-intercepts. And it's not just that, we can actually expand this idea. If we have a factor, x minus b, so something like x minus 2 of a polynomial, then we know that b is going to be a root, or in other words, a solution, to this polynomial when it's set equal to 0. Because we can say x minus b times a whole bunch else will be equal to 0. So we can solve for b. What we also know is that b is going to be a 0 of this polynomial. And that b is also going to be an x-intercept. So all three of these sentences, all three of these things, are the same. A root, b is a root or a solution to this when it's equal to 0, but that also means that b is a 0, and when b is a 0, it's an x-intercept. Same as what we saw up here. B was an x-intercept, which meant it was also a 0, or a solution when we set this equal to 0. Why is this important? Well, let's go ahead and try to graph using just this information. Here we have some sort of factored equation here, and we're trying to sketch a graph. What do we know? Well, we know that x minus b is a solution or an x-intercept, meaning that we have x plus 2. That means that negative 2 is an x-intercept. It also means that positive 1 is an x-intercept and 3 is an x-intercept. So we can graph each of these, we can plot each of these points. at -2, 1, and 3. Now we can also, just like we were doing with the parabola, look at the end behavior to figure this out. What is our degree going to be? Well, we have y is equal to x plus 2 times x minus 1 times x minus 3. So if we just combine the x terms together, we multiply these together, we would get y is equal to x squared plus a whole bunch of other things times x minus 3. Again, distributing this in, we'd have x squared times x, so we'd get an x cubed term plus a whole bunch of other terms. What does this mean? It means our n is odd and our a is positive. That means our end behavior is going to be down, up. So now we know to the left side of this point, we're going to go down. To the far left, we're going down, and to the far right, we're going up. Now all we need to do is we need to plot a couple of points here. Let's test the points -1, 0, and 2 to see what our solution will be. So if x is equal to -1, what is this going to be? Well, we'll have y is equal to -1 plus 2 times -1 minus 1 times -1 minus 3. So we go ahead and solve this. It would be 1 times -2 times -4. So we'll have the point -1, 8. Let's go ahead and plot that. 1, 2, 3, 4, 5, 6, 7, 8. Okay. What about 4, 0? Well, if x is equal to 0, then y will be equal to 2 times -1 times -3. Or that will be -6 times -1. It'll be +6. So we can go and mark a point at +6. And then if x was equal to 2, we could go ahead and solve for that as well. We'll do that over here. If x is equal to 2, then we'll get y is equal to 4 times 1 times -1. So we'll have a point at 2, -4. We'll go to 2, we'll go down 1, 2, 3, 4. And now we have some points. We know what this looks like on the far left and right. Now we just need to connect our points. And there we have a rough sketch of this graph. As a matter of fact, let's go ahead and clean this up a little bit. So we know we're going to be starting down. We're going to go all the way up to this point and back around, circle back, and make our way up. That's going to be the sketch of this graph. Let's do another one of these. Let's actually have you do this. We'll factor this out, and then we'll work from there. So we have y is equal to -x cubed plus 2x squared plus 15x. Let's start by factoring out a -x squared, or a -x. That way we're left with a positive x squared, and we can use the shortcut for factoring. Positive x squared minus 2x plus 15. So we factored out a -x, and we're left with this. Now let's factor. We're looking for factors of 15 that are going to add up to -2. That's going to be -5 and 3. So our factored form is y is equal to -x times x minus 5 times x plus 3. So go ahead and try to graph this from this equation. What do we know from this equation? Well, we know we're going to have an x-intercept at each of these factors. We have -x, so that's x plus 0. So we'll have an x-intercept at 0. We'll have an x-intercept at +5. And we'll have an x-intercept at -3. 1, 2, 3. Now we're going to choose a couple of points to see what's going to happen in the meantime. Let's try -1, and let's do 2 and 4. So if it's negative 1, then we'll get y is equal to positive 1 times negative 6 times 2. Or this will be equal to negative 12. So we'll have a point for negative 2 all the way down here. What about for positive 2? Well, then y will be equal to negative 2 times negative 3 times 5. So this will be way out there. Let's see, that would be 6 times 5, so that'll be 30. Might be a little too tall for us. So let's go ahead and try 4 as well. For this one, we'll get y is equal to negative 4 times negative 1 times 7, or 28. And then we'll use this information to graph. So we get a point 30 all the way up here, somewhere way up there. We'll get 28 down here, and we know it'll be back down to 0 over here. What about our end behavior? Well, we have a negative coefficient, and we have an odd degree. So we have a is negative, and n is odd. If we go to look at our table, that tells us we'll be starting up, and we'll be going down. So now it's time to fit this graph. We're going to start up, we're going to work our way all the way down, back up, and then work our way down. And this is going to be what our graph looks like. Now we have a theorem which just reinforces all we were saying. An expression x minus a is a factor of a polynomial if and only if, this is really powerful language here, if and only if a is a 0 of the polynomial. Meaning that we can only factor this if we know a is a 0. Now why is this theorem important? Well, it allows us to look at something where we can only find the zeros or only find the factors and reverse them. For example, if we have a cubic polynomial that has zeros at negative 2, 3, and 5, what that means is we know the factors are also going to be x minus negative 2, x minus 3, and x minus 5. Or we can say that the factors are x plus 2, x minus 3, and x minus 5. Now we're not quite done here because we still need to expand this out. So let's go ahead and FOIL these first two. We'll get x squared plus, what will that be? Negative or minus 3x. So we'll get minus 3x plus 2x minus 6 times x minus 5. Or minus 3x and plus 2x will become minus 1x. Now how do we do a cubic into a quadratic? Well, this is where we do the box. So we're going to set up a box with each of our terms on the top and each of our terms on the side. So for example, in this case, we'll set up so that we have our x squared term on the top here. We'll have minus 1x, and we'll have minus 6. And we're multiplying that into x minus 5. So this is going to be the same thing as x squared times x, so this will be x cubed. We'll have negative 5 times x squared, so this will be minus 5x squared. We'll have negative 1x times x, so that'll be minus x squared. We'll have plus 5x in this. Negative 5 times negative 1x. We'll have minus 6x, and we'll have plus 30. So now we can solve for this. We can say y is going to be equal to x cubed. Let's combine our x squared. So we have negative 5 and negative 1. We'll have minus 6x squared. What about for our normal x's? We have negative 6 and 5 of those. So that'll be minus x plus 30. And this will be our answer to this problem. Go ahead and try one for yourselves. what will the cubic polynomial be that has zeros of -4, -4, and 1? For this one, our zeros will become our factors, so we'll have x minus the -4, or x plus 4, times x plus 4 times x minus 1. Let's go ahead and FOIL these, so this will become x squared plus 8x plus 16 times x minus 1. And now we'll put this into the box, so we'll have x squared, we'll have 8x, and we'll have 16. And we will have x and minus 1. So we'll have x squared times x, so this will be x cubed. We'll have x squared times -1, so minus x squared. We'll have 8x squared. We'll have minus 8x. We'll have 16x, and we'll have negative 16. Then from here, all we do is we combine our like terms. So we'll get y is equal to x cubed plus 7x squared plus 8x minus 16. And this is our equation that has zeros at -4, -4, and 1. Let's do one more, a quartic polynomial that has zeros at 2, -3, 1, and 3. Go ahead and write this out and solve it. For this one, we'll get y is equal to x minus 2 times x plus 3 times x minus 1 times x minus 3. So let's go ahead and factor both of these. We'll FOIL them. So for these first two terms, we'll get x squared plus 3x minus 2x, so plus x minus 6. And these other two terms will have x squared minus 3x minus 1x, so minus 4x plus 3. Now let's go ahead and make our chart. We'll have x squared, we'll have x, we'll have -6, and we will have x squared, we'll have minus 4x, and we'll have 3. Now multiply these all together. X squared times x squared will give us x to the 4th. We'll have minus 4x cubed. We'll have 3x squared. We'll have an x cubed. We'll have minus 4x squared, 3x, -6x squared. -6 times 4x will give us 24x, and -6 times 3 will give us -18. And now we have to combine our like terms, which coincidentally for this one are our diagonals. So we can just do our diagonals for this. So we'll have x to the 4th. We have x cubed minus 4x cubed, so minus 3x cubed. We have 3, -4, and -6 for x squared. So we have -10 plus 3, or minus 7x squared, plus 27x minus 18. So this is how we solve, finding just our zeros. Now, let's go ahead and graph these two equations and see how they differ. I'm going to be looking at x plus 2 times x minus 1 times x minus 2, and x plus 2 times x plus 2 times x minus 1 times x minus 2. So here we are with both equations. We have x plus 2 times x minus 1 times x minus 2. In this one we have two x plus 2's. Let's go ahead and see how they differ. We'll do a good old zoom standard, make sure we're in the right window. So this first one, we have zeros at 2, which we expected, at 1, and at 2. Looks like it's the same, but this one, the red one, has a slightly different zero. So let's go ahead and sketch out what each of these look like. For this one, we had something at -2, we had something at 1, and we had something at +2, and ended up looking sort of like this. Whereas with the quartic, we still had a 0 at -2, 1 at 1, and 1 at 2. But this time we started up, we just barely touched that, and then we went through for 1 and 2. The reason for this is that we have two x plus 2 terms in here. This is what we call a zero of multiplicity, or a factor that shows up multiple times in a polynomial. Factor or zero that shows up multiple times. So how do these affect a graph? First, let's talk about what a multiplicity is. For this first example here, y is equal to x plus 3 times x minus 2, both of these terms only show up once. So both of them have zeros of multiplicity 1. In this next example, x plus 1 shows up twice. So that means that this is going to have a multiplicity of 2. In this third one here, x plus 1 shows up 3 times, so it has a multiplicity of 3. Now when the exponent on the 0 of multiplicity is 1, then near that 0, it'll act like a line. If the 0 of multiplicity is 2, actually let's go ahead and do a graph for this. So for each of these, x minus or x plus 3 and x minus 2 will have a factor at -3 and +2. We'll expect this to look like a line. It'll go straight through on both of those. Meanwhile, if the 0 of multiplicity is 2, then near that 0, the graph looks like a parabola. And you can go ahead and throw this into your calculator. As a matter of fact, let's go ahead and do that. So here we are with this in our calculator. We expect near -1, this will act like a parabola. And if we look at that, it does look like a parabola. It just sort of kisses the graph right there before moving back down and then going through at 3. So let's go ahead and graph that. At -1, we just sort of touch the graph before going back down and then coming through at +3. Meanwhile, if our 0 has multiplicity of 3, then near the 0 it'll act like a cubic. Let's go ahead and graph this one to see what it looks like. So we've adjusted this so that x plus 1 is cubed. It has a multiplicity of 3. Let's see what happens at -1. And at -1, we see this sort of cubic act. It flattens out a little bit and then continues going down for passing through at 3. For this one, at -1, we saw it sort of flatten out, then curve back down before going back up to 3. So looking at this, it acts sort of like a cubic at -1. For this middle one, it acts sort of like a quadratic. So now let's determine zeros by factoring, and then use a graphing calculator to see the zeros of multiplicity. So for this one, we have x to the 4th minus 2x cubed minus 8x squared. Each of these terms has an x squared in there, so let's pull that out. And what are we left with? We're left with x squared minus 2x minus 8. So we're looking for factors of -8 that add up to -2. What factors will do that? Well, -4 and +2 multiply together to make -8, but add together to make -2. That means that this will look like x squared times x minus 4 times x plus 2. So we have a 0 with multiplicity of 2 at 0. So 0 with multiplicity 2. We have 4 with multiplicity 1. We have -2 with multiplicity 1. Let's graph that and see if we see a quadratic near the multiplicity of 2. So here we have this in our graphing calculator. When we graph this, we expect to see a quadratic near 0, which we do see. We see a little bit of a U there. We see a straight line going through at -2. And we see a straight line going through at +4. So this part, this little U shape at 0, is that multiplicity running into effect. Now we just have one more topic today, which is relative maximums and relative minimums. And all these are, a relative minimum is the smallest point in an area. Well, a relative maximum is the largest point in the area. So if we're looking at this graph and we're trying to determine the relative mins and maxes, looks like we have a smallest point, looks like we have a little bit of a cup here, with the smallest point being here. So we have a relative min, and we say it's a relative min of whatever the y value is at the x value. So this is a relative minimum of 0 because we're at the x-axis. But where does it occur? It occurs at the point x is equal to -1. Now it looks like we also have a second point here. This one seems to be a relative maximum, right? It peaks and then it goes back down. So we'll call this a relative maximum. And it'll be a relative max of the y value, so of 4, at whatever the x value is, at x is equal to 1. So relative mins and relative maxes, just where we shift from going down to up or up to down. Look for these little curves or these little bumps. And folks, that is all we have for this lesson.